Now make sure you watch this video because just because salt hydrolysis and common ion effect are not specifically said in the syllabus, they can occur in the questions because they are conceptual things that you can covered before with equilibrium, and ultimately they're putting you all on a bell curve. So the people that can answer the tougher questions are going to be the ones that get ahead and get the higher ATAR. So the first one we're going to talk about is salt hydrolysis. Now, I think we should just jump to the bottom here. What you should really recognize with weak acids and bases, and we're looking at, say, for instance, this one here. So we're looking at vinegar. These weak acids and bases are actually quite strong in the fact that they hold on to their H pluses and they don't want to give them up. And so when you actually have strong acids and strong bases, so strong acids and strong bases, they're actually weak at holding on to their OHs and their H pluses and actually give them up completely, completely dissociate. So this partial dissociation, which is equilibrium, is because these weak acids and bases don't easily give them up and they hold on to them. And so that's the key in what goes on here. So if you add just a neutral salt to water, such as iron chloride, what's going to happen is, because iron hydroxide is a weak base, this iron is actually going to form that weak base because, as I said before, weak bases are actually quite strong at holding onto OH minuses, or weak acids are strong at holding on H pluses. And so they actually do that. And that means that these H pluses come off and the solution becomes acidic. And you can see here the same if you add a salt. So if you add a salt of a weak base or the salt of a weak acid, this is what's going to happen. I think that this term weak is quite interesting, as I've noted before down here. Okay, so if you add the salt of a weak acid, same thing's going to happen. It's quite strong at grabbing H pluses, and so it's going to grab the H pluses from water, have this equilibrium system going here, and going to make the solution alkaline. In a very similar fashion, there's something called the common ion effect. And so what would happen in the previous situation here is, and this can be applied to all equilibrium solubility pH calculations. When you add a common ion, so if you add a sulfate to this, so sulfate is not going to, because sulfuric acid is a strong acid, so it's not, the sulfate is just going to be quite happy in this situation here. It's not going to go back here, but the iron does form a weak base here, and so the iron is in effect going to come out into solution, and it's basically going to increase this side. So Le Chatelain's principle means it's going to therefore increase this side. So if you add a common ion, in this situation, it's also going to increase the acidity even more. Now, increasing this will also affect the solubility. So you need to have a careful look at maybe some trickier questions that they could give you. There could be salt hydrolysis going on, and there could be common ion effect going on. And that is plenty of ammunition for them to give you those slightly harder questions to separate those out on to who gets to the very end of that bell curve to get that 99.95.